Hello guys, and welcome to another video. On this video we'll be looking at finding the theoretical yield. Okay, we'll be looking at finding the theoretical yield. How do we do that? Okay, this is how we do it. Firstly, let's read our statement. It says we have sulfur dioxide which reacts with oxygen gas to produce sulfur trioxide. Then they say 1,8 kg of sulfur trioxide is formed from 2 kg sulfur dioxide. Then calculate the theoretical yield of sulfur trioxide. Now, for us to solve this problem, guys, we firstly need to have a balanced equation, as we are going to use the coefficients of our substances in order to proceed and get our theoretical yield. But the problem here is that we do not have that equation, so it means we have to actually come up with that equation. We have to draw it up. And how do we do that? Well, we see here that we have sulfur dioxide which reacts with oxygen, so we need to understand what is sulfur dioxide. Well, sulfur dioxide will be as follows. It will be SO2, and then reacts will be our plus with what? Oxygen. And oxygen will be O2 since it's a diatomic molecule or gas. So oxygen will be O2. To produce means that we will have our product of what? Sulfur trioxide. And that means the arrow is me producing what? Sulfur trioxide. And sulfur trioxide will be SO3. And this now becomes my equation. But the question is it balanced? And the answer is no. How do we know that it's not balanced? Well, let's firstly look at sulfurs. If I look at my sulfurs, let me change my color of pen. If I look at sulfur, see I have one sulfur this side and this side. So at the moment sulfur seems to be okay. I don't have to worry about it. But when I check my oxygen, this side I have 2 oxygens plus 2 oxygens, so that means I have 4 oxygens. In this case I have 4 oxygens, but when I come this side I only have 3 oxygens. Can you see that? That means my equation is not balanced in that regard. So the question is, how is it that I'm gonna balance my equations? Well, there's a method I use, or I don't know, system. Let me say system. The system I use is called the crisscross system. How do I work with the crisscross system? I work with the crisscross system by saying, okay, since I have 2 oxygens this side, well, I focus on 1 oxygen, by the way. I'm gonna take this value and put it here as my coefficient because I have 2 oxygens, right? So I'll take this value here at the bottom and put it up here as my coefficient. So now it means I have 2 sulfurs on the right, and if I multiply this 2 with this 3, I now have 6 oxygens on the right. Now that I have 6 oxygens on the right, I'll check how many do I have this side. Well, remember we said it's 2 plus 2. That means I have 4 oxygens. So the big question is, how do I get these oxygens to also be 6? Well, this is what I do. I realize here that my sulfurs on the right are now 2, whereas this side I only have 1 sulfur. So that means I'm just gonna take this 2 and put it here to make sulfur to be twice on the left, just as it is on the right. And once I'm done with this part, now I check my oxygens. I see that sulfur is 2 here, even this side. But what about oxygen? Well, now that I have this 2 up here, I'll say 2 multiplied by 2, and that gives me 4 oxygens plus this 2. That means now I have 4 plus 2 oxygens, and they will give me how many oxygens? 6 oxygens in total. And this means my equation is now balanced. I have 6 oxygens on the left, I have 6 oxygens on the right, 2 sulfurs on the left, 2 sulfurs on the right. My equation is now balanced, and after my equation has been balanced, it means now I can finally proceed to getting my theoretical yield. Okay, how am I gonna get my theoretical yield? Well, I see that I'm given the mass of sulfur dioxide. So the mass of sulfur dioxide is given as 2 kg, and then I'm looking for this mass. Me looking for theoretical yield is me looking for the mass of sulfur trioxide. So what I'm going to do, guys, is to say, okay, because I want to end up having this sulfur trioxide, I need to lose this sulfur dioxide. Okay, thus I'm gonna use this 2 kg mass of sulfur dioxide to get my theoretical yield. But how do I do that? Well, I will use this mass of sulfur dioxide to get the number of moles of this substance, which is the sulfur dioxide. So what I'll say is N is equal to, okay, let me just say N of sulfur dioxide is equal to mass divided by molar mass. And then from here I will substitute my mass with 2 divided by the molar mass of sulfur dioxide. How do I find the molar mass of sulfur dioxide? It's M in brackets SO2 is equal to 32, which is the molar mass of sulfur, plus 2 of what? 2 of my oxygens multiplied by the molar mass of oxygen, which is 16. So 32 plus 2 times 16 will give me what value? I believe it's going to give us 64. We can confirm 32 plus 2 times 16 is, the value we get here is 64 grams per mole. That's how we get our molar mass. So it means here for this big M, I'm gonna put 64, and then from there I go to my calculator to say what is 2 divided by 64, and the value I get here is going to be 0.0312 K moles. Now there's something here, guys, I want you to be aware of, that when you are finding your number of moles, which are going to lead you to finding the number of moles of this substance and then the mass, make sure that you round off your answer to 4 decimal places. You will only round off the final answer to 2 decimal places. And the reason why I'm saying this is because in the previous video I found the number of moles and rounded off the answer to 2 decimal places, and that made my answer to be inaccurate. So for us to have an accurate value, let's round off to 4 decimal places and then to 2 decimal places at the final part of our answer, or on the final part of our answer. I hope that is clear. Now that we have found our number of moles, we are now going to use these number of moles to find the number of moles of this substance, because we need the number of moles of this substance. How are we finding those number of moles? We will be making use of ratios. Okay, let me just erase some of the mess that I've created here. Okay, now that this mess is gone, let's work with our ratios. When I look at my ratios, guys, I'm gonna deal with the ratio of the substance that I have information about and the one that I don't have information about. So here we see that I have information about sulfur dioxide. I know the mass of sulfur dioxide. I also know the number of moles, but the main thing I want are the number of moles of sulfur dioxide. So what I'm going to say is SO2 is to SO3. I write these two substances in a ratio format. Then after that, I'm going to put down their number of their coefficients, which will give me my ratios. And you see that the coefficient of SO2 is 2 and the coefficient of SO3 is also 2. So my ratio is 2 is to 2. After here, I'm gonna write the number of moles of these two substances. What are the number of moles of SO2? They are 0,0312 is to what are the number of moles of SO3? I do not know them, so I'm just gonna put N there. But I'm noticing that my ratios are the same. I have 2 is to 2. 2 is to 2 means that this substance of SO3 will have the same number of moles as those of SO2. Why? Because the ratio is 2 is to 2. So I'll conclude here by saying N of what? SO3 is equal to 0,0312 moles. And then once I've found this number of moles, what am I doing to proceed? I will use this number of moles of SO3 to find the mass of SO3. And the formula I'm going to use to do that is N is equal to small m over big M. Okay. Then I will make M my subject of the formula. So when I say M times 1, I get M is equal to, if I cross multiply, N times M will be N big M. Then from here, I will now find the mass of SO3. Finding the mass of SO3 means that I'm going to say the number of moles of that substance, which is 0,0312 multiplied by the molar mass of that substance, which is 32 plus 3 multiplied by 16 is equal to, and then from here we'll go to my calculator. Where do I get these values, guys? The 32 and the 16, I get them from my periodic table. And here's my periodic table. The molar mass of sulfur is 32 and the molar mass of oxygen is 16. I hope you understand that part. Okay, where is that question we are doing now? Let me just find it. Okay, so I found our question. Now, remember we said that we'll multiply our number of moles by our molar mass. So let's do that on the calculator. I will have 0,0312 multiplied by 32 plus 3 times 16. And the value I get is going to be 20, or rather 2, it's going to be 2 comma, if we decide to round off to 1 decimal place, or I don't know, let's round off to 1 decimal place. So it's gonna be 2,5 kg. Okay, or you might have gotten 2,4, yeah, but yeah, 2,5 kg, guys, is the best answer, and it comes from 2,496. So if I round off this to 1 decimal place, I get 2,5 kg, and that's your theoretical yield basically. Okay, we can use this to find the percentage yield, but in this case, this is where I'm gonna end things. I hope you understood this. If not, please do try to rewind the video, watch it once more. Guys, do like the video and subscribe to the channel if you haven't. And yeah, I'll see you on the next one. Bye bye.